and I always love to steal people's thunder, so I'm not going to. Please help me welcome Eric.
I'm recording my screen.
Yeah.
There. It's recording.
That's recorded. Sweet.
Audio is good. Audio is good.
Well, both, since he's hooked in to.
All right, thank you guys for coming today. For those of you who came to the December meetup, as Tyler mentioned, there was a shorter version of this presentation then. I misread the instructions and I prepared a longer presentation than 5 minutes. So you guys saw the abridged version in December. We'll go over that again and go a little bit deeper into Normalizr. This presentation will be about 20 minutes. The goal isn't really to get you to the point where you are a master of Normalizr, but rather to introduce you to the concepts of Normalizr, tell you what problems it solves, why you might want to use it, and how to get started using it and where to look. As Gordon mentioned, there's a AZ Web Dev Slack channel, which I'm also on, so if after this you have more questions about it, feel free to reach out to me on there. And these slides, if it's hard for you to read these, there's a link to these slides here. It's also, I posted that on the comments for this meetup group, so if you want to follow along, or if you get bored and want to look ahead on your own computer, feel free to check out the slides there. All right, so whenever I start thinking about a new technology, I like to first understand what problem it's meant to solve before I start using it. So the problem of React Normalizr is how do you deal with very deeply nested data inside a front-end application. So this is a screenshot of the product at Brightguest. At Brightguest, we develop software for restaurants. So if you go to a restaurant and you give them your phone number, our software will text you a link to a page that you go to, and then that page gives you stuff to read while you're waiting. So this is a screenshot from the dashboard where users can set up the content that people will look at on their phone. So what you're seeing in this column is the first bin, which people go to when they enter the restaurant. And this column is the second bin. These bins have what we call cards. This is a card, this is a card. And the bins can have the same cards in each, 2 bins can each have the same card. So this card is the same in both of these bins, this card is the same in both of these bins. So one of the problems that we need to solve is when someone edits this card, for example, changes one of these form fields, which is inside the card, we need it to update both here and here. So React Normalizr gives us a set of tools to make dealing with that deeply nested data where you have survey questions, inside cards, inside bins. That's a deeply nested data structure, so Normalizr gives you a good way to deal with that type of data structure. So this is behind the scenes, this is the data structure that this is being rendered based on. So we have the parent object is an array of campaigns. Inside campaigns, we have these bins, which are those 2 columns. Inside the bins, there are cards, and inside the cards, there are survey questions. So that's sort of how the data is structured. In our actual application, there's actually probably 3 or 4 levels more deep, but this is sort of a simplified example where there's just campaigns which have many bins, which have many cards, which have many survey questions. So sort of a naive way to deal with this when your data is structured like this, when you get new data, so when the server sends, when you want to update the question in a survey card, for example, you need to write a reducer, which then has to go find any references to that survey card and update them in all the different places it might be. So if this is the data structure, right here, or if this is just one card, there's another card down here, or maybe there's another bin which has another card which has the same data for the survey questions. So when we get a new updated survey question, we need to go find it in all those different bins, which leads to very clumsy reducers, which kind of look like this. They're kind of hard to maintain. They're fragile. If you ever change the structure of your data, you have to go change all these reducers. It's very hard to debug, and they're no fun to write. And worst of all, there's a lot of code duplication. So this is in the campaign reducer, we have to worry about survey question updates. Because every time survey question updates, we need to update each campaign in case their survey card has changed. So there's also a survey card reducer, which does a similar thing. And maybe there's also a bin reducer, which does a similar thing. And maybe also a card reducer, and all these things are sort of doing the same thing, but not exactly. So the solution to this problem is to use Redux Normalizr, which is a library now maintained by Paul Armstrong, but I think it was originally developed by Dan Abramov, who's also the creator of Redux. So what does Normalizr do? So Normalizr will transform your deeply nested data structure. This is what was from a few slides ago. We'll transform that into this, which is a much flatter structure with a single function call to normalize. So we're looking at exactly what's happening here for a second. So originally we have a campaign object, inside the campaign object there are bins. Inside the bin object there are cards. Inside the card object there are survey questions. After we normalize the data, we now have at the top level of our object, we just have campaigns. Each campaign contains an array of bin IDs. And then there's also at the top level, not nested in the campaigns, an array of bins, which contains its ID and an array of cards that might belong to that bin, and so on and so forth. So no longer do we have this deeply nested data structure. Instead, everything is flat at the top level, and this makes it a lot easier to work with our data, as we'll see in a second. So the flip side to normalizing, again, might be a little bit hard to see in the back, but there's just one function call needed to transform this data structure into this data structure. It just takes the object, the deeply nested object, and the schema, which describes how this data is structured, and we'll talk about that in a second. So once you have normalized data, you may need to denormalize it. For example, in the component that shows the campaign, we need to show each bin. And so in order to do that, we need to have all the data for all the bins and all the data for the cards and all the data for the survey questions. So there's a library called Denormalizr, which just does the opposite. So if we have the normalized data for a campaign, which is just the campaign object with an array of bin IDs, not the actual data for the bins. Denormalizr will take that normalized data and repopulate it with all the data that was taken out when we normalized it. And again, that's just one function call. Maybe hard to see in the back again, but it's just a call to denormalize. You pass in the normalized campaign object that you want to rehydrate to denormalize. And then you also pass in the all of the normalized data that you know about. So so you also need to give it the data for the cards and the bins and the survey questions. You also have to give it the schema. So what are these schemas? They're very simple objects that just describe how your data is structured. So this is an abbreviated example, but not too much abbreviated. So all we have to do is tell Normalizr and Denormalizr that campaign has many bins, and each bin is an array of bins. Campaigns have this property bins, which is an array of bins, which are defined here. And the bin schema says that each bin has a property cards, which is an array of cards, which we would define down here, and so on and so forth. So the schemas are pretty simple objects. It's easy to update them when your data structures change. It's easy to update them if you need to add a new data structure. And overall, this is a much easier, less fragile, more sturdy system to manage your front-end data. So the strategy that we took when implementing Normalizr in our application was to normalize in the reducer. So the animations are a little off here. So we have a single reducer which handles all responses from the server. So anytime our front-end application learns about new data from the API, it needs to run this single reducer. So we no longer need to have a cards reducer, a campaigns reducer, a bins reducer. We just have one reducer, which we call the entities reducer. And then that reducer normalizes the data and shallowly merges it into the slice of the store that it maintains. So this is the normalized data, which I showed you a few slides ago. This is the data that goes into the entities store, which is managed by this entities reducer. So whenever the entities reducer learns about new data from the API, it just does a shallow merge of that data into the store, overwriting whatever else was there. So if there's an update to a survey question, for example, so say we need to update survey question with the ID 400, instead of trying to find it in all the different campaigns by looking through each of their bins, through each of their cards, we just need to update it in one place, which is at the top level of our entities store, which is where the survey questions live. And that's the only place that the survey questions data is in our front-end application. So we normalize the data in the reducer, just using a call to the normalize, which is just a single function call. And we pass in that set of schemas. And then we denormalize in selectors. So in the component that needs to have all the data about a campaign, for example, that component that I showed you at the very beginning, where there's two columns, one for each bin, we need to denormalize that data structure. So we do that using selectors. And selectors just query that slice of state managed by the entities reducer, which I showed you before. And so there's another library called reselect, which we use, which does memoization, because denormalizing can be a little bit expensive. And calculating it once, if your data hasn't changed every time you calculate it, you're going to get exactly the same results. So we're able to memoize that and speed up our application by using a library called reselect. That's not strictly necessary, but it can help you with performance issues. So let's take a quick look at how these selectors work. So this is how these are reselect selectors. So the syntax may be a little bit different from what you're used to seeing. But we first have an entity selector, which just grabs that entity store, which I showed you a few seconds ago. Then we have a selector which is responsible for getting the normalized campaign out of the store. And it just does that by passing an ID to it, and it grabs that campaign. So that's just that object that I've shown you a couple of times, where there's just a campaign which has an ID, which has two properties, an ID and an array of bin IDs. And then we have a selector which is responsible for denormalizing the campaign. And all it does is just call denormalize and passes in the entities and the normalized campaign and the schema that we defined previously. So when you have a map, in your map state to props function for your Redux connected component, it's quite simple to get that denormalized campaign. So you just have to call this selector and pass in the campaign ID, which reselect then hands down to the composed selectors. So that's all great. It works really great, except for there's a couple of tough parts. So one of them is, how do you handle deleted data? So when a record is deleted, you need to delete any references to that record ID. So when I was first researching this, I found this comment by Dan Abramov. He said he found two options. One of them is just reload your application if you don't delete very often. I guess that works. You won't have any references left after you delete and refetch the data, because the data has been deleted from your server. But that might not be the best user experience if every time you try to delete a survey question or delete a card or delete a bin, the whole application reloads and it takes 5 to 10 seconds, depending on how fast your internet connection is, to get the data. The other way he suggests to do it is to make deletion a status rather than a real deletion. So he suggests that you may just add a deleted property to your object when it gets deleted, and then make sure that you never try to render a deleted an object that has that deleted property. So that's the route that we went. So now when our API deletes something, it returns data. So if we delete the campaign with ID 100, for example, our API returns this object, which is just a campaign with ID 100 and the property deleted and no other data, so no more list of bins, for example. And when that's true, so our entities reducer, which I showed you earlier, will run this through and do a shallow merge of this campaign into the campaigns list, which means it will replace the campaign that had bins 100 and 200. And when that happens, we need to make sure that when we select campaigns, for example, if we have a list of campaigns, we want to remove that deleted item from it. So to do that, we just use a simple helper function, which checks to see if an object has the deleted property. And if it has the deleted property, it'll just remove that from whatever it's returning. So if you're returning an array, it'll filter out deleted objects. Same thing with an object. And so that way we can manage deleted data without refreshing the whole application. We just have to make sure we always filter out the deleted objects. Otherwise, weird things happen in our application. So another tough part here is when you need to add a new child to the parent. So for example, if we need to add a new bin to a campaign, this is what our campaign looks like. It has 2 bins right now, and we want to add a 3rd bin to it. So we want to add bin with ID 300, but this is how our component works right now. We're rendering something where we get the bins by just checking the campaign, getting the bins off of the campaign, and the campaign is just the denormalized campaign selector. If we add a new bin and just return that bin's data from the server, this campaign doesn't get updated. Because instead we'll just have a new bin, which is down here in the entities reducer with ID 300 and campaign ID 100. But when we denormalize this campaign, Denormalizr isn't smart enough to look at the entire state of the entire entities reducer and find all the references to the campaign. It goes the other way. It just looks at the list of bins and denormalizes each of those. So if you just return the bin from the server, this gets merged into the entity store, like I was saying, just below here. And then when we try to denormalize this campaign, it's not going to know about bin 300. So there's a couple of ways that you can solve this. One way is a bit lazy. It's just to return the entire parent every time you add a child. So this is an example of how you would do that when you create bin with 300. If you return the entire campaign, all of the data for that campaign, then this will get normalized and bins will just have 100, 200, 300. That's one way to do it, but there are some downsides. For example, you have to transmit a lot more data back and forth. If this kind of feels wrong to return data about a campaign when you create a new bin, but it is very easy to implement that in the back end. But another way to do it, which is probably a better way, is to if you have this problem if you are getting the bins out of the denormalized campaign, but instead of doing that, if you instead so this line right here, well, if you are using this to get the list of bins in your render function, I don't have the render function here, but if you're using this to get the list of bins for your render function, then it won't update if you just return the bin data from the server. But if you use this line, which it uses a different selector, a bin selector, then it will update. So the bin selector works by just filtering all of the bins that the application knows about and checking their campaign ID rather than going the other way where you look at that campaign and look at all the bin IDs. So that's a very brief overview of how Normalizr and Denormalizr work. Those are two of the toughest parts. There have been other struggles that we've had, and I'm sure you guys will have them too if you try to implement this function. So feel free to reach out to me if you have any questions. I hope this was enough to get you interested in this concept and to understand the problem it solves so that you can consider using this in your project. So are there any questions? Yeah.
Can you go over the need for denormalization? I've used Normalizr, and you take your deeply nested entities from your API and normalize them. You can just index into those entities. Why do you need to denormalize in your component?
Yeah. So that's sort of what I'm hinting at here. Is you don't need to denormalize. So here, instead of denormalizing, you can just grab the bins directly out of the normalized store.
Right.
So actually what happened for us is we had developed a lot of our code. Maybe 3 months of our project was spent without Normalizr. And so all of our components were built with this assumption that campaigns have a bins object inside it,
okay,
which has nested bins. So we wanted to switch to Normalizr to avoid writing those nasty reducers. And when we did that, suddenly all of our components broke because they no longer had the assumption that it would have bins. Didn't work out. So using Denormalizr has led to problems, but it also let us sort of retrofit Normalizr into our existing code.
But okay, I guess as a little bit separate than that, in your reducers, wouldn't that be the place where you delete entities that no longer exist on the server?
So deleting the entity that was deleted isn't the hard part. The tough part is
I guess, is that a side effect because you had to denormalize it?
Yeah.
That's why you had to do it that way?
Yeah, exactly.
Okay, all right, that's all.
Yeah, same thing, referencing it, right?
Any other ID referencing it? And
right. So the problem for everyone else is that when you have, so if you have a campaign object that has bins 100 and 200, when you denormalize this, it's going to look for bins 100 and 200. But if your bin 200 gets removed from the bins set of the state that it's using to denormalize this, this reference to it still exists, and if it's missing from the bin store, you're going to have problems. So it'll be undefined at best, and you might get some sort of runtime error.
Gotcha.
So that's why we keep them there. We just tag them as deleted. Anyone else have questions? All right, well, thank you guys very much.
All right, while we're setting up the next presentation, we're going to have a 240-second break. You can hit the bathroom if you need to, but you can mingle in the meantime. 240 seconds. 240,000 milliseconds. Thank you, Garrett. Did you see the person walk out? Get started with the next round. Anybody who's not here is fine. They'll just come in and make their way in. We're going to get started with our next presentation. So, Ivan Montiel, is that easy? Sure. Close enough? Yeah. I don't want to do the whole thing where it's like, I can't quite hear it. Okay. So, Ivan works for Bolst, and he's been doing React for quite a while now. So, he's an expert on higher order components, and he's going to show us some of the things, the techniques that they're using at Bolst. So, help me welcome Ivan.
So I'm going to talk about higher order components. I'm Montiel, work at Bolst. We do a lot of we do collaboration software there. So higher order components have really helped us out with our workflow. And I'm going to go over what is a higher order component in case some people don't know how to implement them in your current workflow. So you're not like writing like weird special things just for writing higher order components. You're using components you've already written and being able to enhance them. And then I'll give an advanced example. I'll kind of go through like a little story along the way about in each section here. I don't want to go over why higher order components before I go over like what they are. So what is a higher order component? I love math, so there's a little equation here. But basically, if you have a function that enhances a component, returns a component, that component that's returned is a higher order component. Just like if you have a function that returns a function, you get a higher order function. So F is an enhancer function, C is a component, that's probably what I'll say most of the time, is your higher order component. Cool. So basically, if you have a function passing a component, you get a new component out, boom, done. That's probably looks familiar if you've ever used React Redux. Connect function, calling a function, this returns a function, sorry. You're calling a function with a component that returns a component. That component has been enhanced with data, so it is a higher order component. Cool. So let's see how we can implement this in our current workflow. As I walk through this, I'm going to start with a component that's like really simple, and we'll start enhancing it and writing functions to enhance it. And along the way, we'll just kind of stumble upon the idea of a higher order component. Cool. So I've got a color swatch. We're working on a really simple app here. Basically, just a height of 100 pixels, width of 100 pixels. You can set the color and other properties, and you can render it. and it'll look like that. Cool, we have a red color, a teal color, we've got some color swatches, we render them, they look like that on the left, your right-hand side. But, you know, as we're working through our app, we realize that we have this common color swatch component, but we make a lot of red ones and make a lot of teal ones. So it'd be cool if we could just decorate the color swatch with those colors and be able to reuse those and like kind of like stamp them everywhere. So maybe we'll write a function called with color. Given a color, we'll bind that color to the color swatch. And we can do that, and we get a red swatch and a teal swatch with those colors. And we can reuse them over and over and over again. So now we have the same thing, but we've enhanced our workflow because now we can reuse the color swatch and the teal swatch without having to know what those colors are or what those properties are exactly. There is a problem with this though, and that is, I'll go back. If anyone notices, we lost the ability to put extra properties on here. So you can't put like an on-click handler or on double-click or anything like that. You can't change the other properties. So what are we to do? Well, we'll make it even more generic than that. We will have a function that takes a color, return a function that takes properties that will return our component. So we're going to kind of just adding layers here. So I can bind the color, I can bind other properties. Because of how React can render components or functions, I can just write the same thing I just did, and it works with on-click handlers now. Cool, so it'll pass props through. Any questions so far? I'm kind of going through this really fast, but we're kind of just building up. So let's generalize the enhancer even more. We can have a create enhancer function that takes options, returns a function that takes a component, returns a function that takes properties, and that will give us our enhanced component, so higher order component. Why do that? If I go back, you see that we're still using the color swatch hard-coded in here. So we can generalize this with color and just say, you know what, we're actually writing a function that's just create enhancer. So find some options, bind it to a component, bind it with some new properties, and return that. And that is what I'm doing here. So I can create an enhancer. So now I can actually call that on any component, and it'll enhance it with this color, which is teal. So I have a teal enhancer to pass around. That's a function that takes a component. So I can just say teal enhancer color swatch. And now I get a teal swatch higher order component. And just like before, I can do that with the red swatch, teal swatch, and use them over and over again. Now I've taken our color swatch, enhanced it. I have a new component that I can reuse throughout my app. Cool. So that, we'll go back before that. That's higher order components. That's really cool. You get to reuse components that you've already written in new ways without having to worry about binding the same data over and over again. Before I go into the next part, any questions? So now you're all experts on higher order components. Congratulations. So, all right. Like I said before, the connect in React Redux just gives you a higher order component back. So in this next section, I'm going to write our own connect whatever function. So after this, you'll be able to write connect user, connect networks, connect tasks, anything like that. And the reason we would want to do this before I get into it is in your app, you might have data for users that you have to fetch. You might have data for tasks, docs, notes. This is all stuff that's in Pulse. It all is interconnected. So if you go to read tasks, you'll want to make sure that you've read users as well so that you can show which users have created the tasks. You can mention other users when talking on a task, things like that. So when you go to write your component, you're going to want to connect it, right? And when you connect it, now that component that's about tasks has to know about the data source of how the reducer works kind of for your users. And when we're writing our app, we found that that was one of the main problems when we, one of the main problems that we had when we wanted to change things drastically. Now we have, if we wanted to change users and how users work, all these other parts of our app that depend on that user stuff is like all over these connect statements. So map state to props, map dispatch to props. So what if we move that stuff, move it to a component, and then turn that component into a higher order component that we can connect and use just like we use the React Redux connector. That's a lot of talking, so let's get to it. Start really simple, have a user card, pick a name, show the name. Really simple. But But what we want to do is connect this somehow. We don't care how the data gets loaded in. It might be cached in local storage. We might have a cache miss, and we might have to go to the server and get it. So we don't care how we get this data. We just want to display it. So the next part is I'll write a component, which might be a little weird to some people. I'll write a component that will load the data for me. So this is a lot of code, but basically all it's doing is, by default, we'll have a name of loading. 2 seconds later, I'm just going to set my name to Ivan, and we'll render our children with those props. So that's all this does. It's just a user loader. These would get really complex in real scenario where we might have cache data in our reducer. If we're using Redux, we might have that data in our local storage, load it in. If we have a cache miss, we'll go ask the server for it, put it in the storage, and render it. So that can get really complicated. But let's abstract that away. Let's put it here. So normally what you would write is user loader, user card, pull it out. The problem with this is it's just really annoying. So your user loader, like whatever is going to render your user card, now has to know, oh, well, you have to wrap your user card with your user loader, or you can wrap that with your user loader and pass down the data. But what really cares about the data is the user card. So what we found was we'll often write many connect statements, right? It used to be people would only write one, pass data down. Now it's kind of like everyone's realizing, no, it's okay to have many connect statements. And so you would just probably put the connect statement with the user card. So why not do that with our user loader? So we'll turn our user loader into a connect user type function that works just like React Redux, and we'll have it enhance the user card. Cool. And that will return a higher order component. So we have our create enhancer. So we're just going to enhance our enhancer function and create a create connect function, which is a function that takes a component that returns a function that takes options, which returns a function that takes a component, which returns a function that takes properties, that returns a new rendered whatever, which is the wrapper and the component that we're going to show. Cool. And that makes sense here. So a wrapper will be what we're going to decorate with the new component. Options will be passed into that wrapper. The component will take all the properties that a wrapper will pass down, and the properties will be given to the component as well. So in the user loader component, we would just say export default create connect user loader. So now we have a higher order component of user loader. Well, sorry, I shouldn't say that. This will return a function. That will return a function, which is exactly how React Redux works. Here, I'll import that connect user code, and I'll just say export default connect user card. And if I wanted to, I could pass options into here just like I would map state to dispatch, or map state to props, map dispatch to props. I could pass that stuff here, and that would get passed to the component user loader. User loader can know what to do with that. But here I've connected user card to my, however I load a user. So that would work just like I would normally do connect with React Redux. And so now I'll talk about why. Why would you do that? You can enhance components with components you've already written. So if you're probably using like the Bootstrap React, what is it called? React Bootstrap. You'd have your buttons. With that first couple of examples, you can theme your buttons and just reuse those themed buttons without having to constantly go through and say, okay, well, this button is going to be red. Put the red property on there. You can just say, we have something called a red button. Use that everywhere and just enhance your components that you've already written. Reuse components with options and prompts already set up. So if you have a user loader, like I said in the previous examples, you can just use that with options, like you have default options on how to load a user. You might want to pass in different href, where that user is located. You can always do that. So reusing components that you've already written, enhancing them to create higher order components. And then I have a pen, all this stuff on there. If you really are interested, it has all these examples on there, and you can tinker with them. When you reload it, it just shows that last example where 2 seconds later, it'll show Ivan. So all that is, scroll down. that part down there. This is some extra code you don't have to worry about. Basically, pre-connect user loader, exactly what I just showed. Connect that user, create a component called user equals connect user, connect that user card, and then just render that. It's a lot harder to see, but it's just code I've already gone over. So render a component called user that's just connected to the user, however users are loaded, and that will just render the user card with however users are loaded. And we also have all that stuff in React HOCs. It's really simple code anyway. I mean, you can just copy paste that and it works. React HOCs, you can just import that stuff. You don't have to rewrite it over and over again. This also will, when you do create connect, it will decorate the component with a displayable name so that you can actually read it when you're debugging using the React dev tools. So this is like a full example on how you might use these, how you might use the connect factory and things like that. So we have that stuff on GitHub. We have a pen. I'll post these slides on the meetup. Any questions after that? That was a lot of code to go through. I kind of went through it really fast. So.
I have a silly question, but I don't think one. Please explain to me how the JS is written in code there. Because all these are they just consecutive and you're just not importing them as
yeah,
components?
it's one huge. It's just one huge file. Unfortunately, I can't show the import-export stuff on here, which is
it's great.
clean it up.
Answer the question.
Have you ever used Recompose?
Recompose, no. They're cool. Is it way better than this?
Well, I wouldn't say that. I wouldn't say that. It's made for building HOCs. It's been around for a while. I can give you the URL.
Yeah, send it to me. That'd be awesome.
Okay.
Yeah, if somebody's written it, I'll kill those.
I mean, you might be doing. I haven't looked at your code yet. You might be doing something they're not doing, but like they'll do. I mean, theirs is more Redux oriented, I believe.
Oh, okay, yeah. This is like really general, where
You can do both with
Yeah.
it, but I was just curious because I've seen a lot of people use Recompose.
oh,
Post it on. Because I'm gonna forget.
yeah, that's a good
I'll do
idea.
that
Put it
right
on
now.
the meetup page.
And that gets posted.
Can you show your user component here?
This one, the user loader.
Just the user, because at the bottom weren't you?
Oh yeah. That's just I had to name it.
Oh, got it.
Yeah, so I just had to give it a name so that I would render it here. I mean, I could have just put it as an anonymous function.
So can you go back to user card then?
Because none of those.
And that's just taking a name and displaying that name that's given to it.
Okay.
The real bulk of the work would be in user loader, and that's just however we're going to load user data. In our case at Pulse, we have our reducer, we'll have a key value stored, where the keys are hrefs, the values are objects. And so if they exist in there, we'll just show that. If they don't, we have a cache miss. So we need to go load that data, put it in the store, and then display it. So we usually put that logic in a loader because not only that, but the data we might be looking at might be paged. So now we have to make sure that we can page through that data. And we might have many different pieces of different views that we're looking at that are paged at the same time. So we can't put all of that in the register.
I'm not seeing the connection on how generic this is. So this has to pass in name and get that from.
The user loader would pass down data, any data. And so the user card is just looking for the name of that data.
So what if you have a collision to, because
Oh, yeah.
so if it's an HOC, you can kind of change
You
it
can change it
all
to the
around.
other, yeah. So the one that we actually wrote, like the full one, allows you to like remap data. So then you would just be able to rename it if you wanted to.
And have you actually had to use that? Have you found yourself going like that's a good pattern to rename it to avoid collisions? Or
we check if like if we have a function in React HOCs which lets you find many different connect statements, just like in a row, nice and neat. And what we found was that we would at each part rename whether each section is ready. So if we're loading, what is it, like I think one of them has 3 different pieces of data. The only way to make that view is if all 3 are ready. So in order to check that.
Hey guys, who's ever talking back there? Can you quiet down? I can't even hear the guy I'm sitting right here.
So we have 3 different sets of data that we're loading in. They might come from 3 different places. In order to show the view, we actually have to make sure that all 3 are loaded in. And so what we do is we say it's ready, and then we pass that down. And the next component will just pass the ready prop statement up from it. So that one would say that I'm ready, and so on and so forth. So the bottom one would just say, like the user card would say, like, is this data ready or not? That's where that would check that. Now renaming stuff, usually it's just each component will try to name things like uniquely.
Okay.
So you name it uniquely. So I mean,
We say like user ready instead of just is ready.
Okay.
Or is user is what's a good example? Task ready. If the task is going to use a user. Things like that.
so at the kind of the leaf level, they never have to be aware though that something is loading them.
Yeah. So when at this point we would just say like, are these things ready? If not, don't show them.
Okay.
But it doesn't know how that data is getting passed to it.
Cool.
So you, like I said, you're writing your component just like you normally would. And then these, like, however you're going to enhance your data, that's where you're caring about passing data down. Any other questions? Okay, you have one question. Seeing how study this tonight. Yeah. Cool. Great, thank you then.
Okay, cool. Well, we have one more presentation, so we'll break for 120 seconds, so you can hit the bathroom if you need to. Sorry, I didn't give expectations about how long this was going to go, so if you need to take off, that's cool. But we'll Brian's going to show us something in 2 minutes. Okay? Sweet. Started with our third presentation. This is an exciting treat because I didn't even know that he was writing this next material, so this is a treat. Bryan, who works at GoDaddy, who we can introduce Bryan. Check it out. I'm excited to hear about this talk, and it looks to be on performance. Bryan Focht.
Actually, before I get started real quick, Tyler told me that I'm running the February meetup.
Oh yeah.
And I'm responsible for finding a speaker. So, are there any topics you want to hear, or does anybody want to volunteer to speak in February? It doesn't have to be a full 40-minute.
If there's a good topic, I'll speak.
Okay, absolutely.
Yeah.
Is there any topics?
Wow, you can just talk on anything? That's impressive.
Yeah.
There's some new things out there. Has anybody looked at Inferno? I know Dan Aberon has been doing a lot about performance of Inferno. Some new React Native stuff. So let me know. Post it. Post it on the React meetup. It'll help me a lot. Save my skin. So I can get that going. Okay. So my talk is, yes, performance. So actually, I gave a quick talk last month of performance that drop-in replacements you can use for React. They're real small frameworks that just drop in. React isn't quite drop-in, it's pretty close, but React-like is a direct. There's actually, I don't know why that's on there, but there's a few others out there you can look at. But another tip I want to give this month is removing propTypes from your production code. So when you're developing your React components, and that is not showing up. Let me reshare. You have your propTypes down here, and you tell it the type and whether it's required. And that's really helpful when you're debugging your code. For example, am I running right now? Yeah. So I have my propTypes out here. It's a real simple component, and I have an index on there that's a number. So if I were to go in here and let's say change that to string and save it, you'll see I'll get a warning. Hey, you're trying to put a string in, or you define a string, but you're passing a number in, right? And so React's very helpful on your debug there.
Let's just go for the list. Do we have that list? Yeah, the sign-in sheet.
Cool. And but what happens is in production, that code actually is ignored. It says here it's not stripped out, it's just ignored. Well, why are you having that code in there, or why put it in your production if it's just being ignored? And I can actually give an example of that. If I were to run my production server, and let's clear that. You see that that warning is there right now. I think without running production, that will be stripped out when I'm actually connecting to a production server, running in 5 mode.
So how did you find this? Like, how did you know that this is something worth my time to strip out?
I think it just came up in GoDaddy. We have a JSTC, a Java Technical Steering Committee. And we have every other week a React topic we talk about. And so I think somebody had just kind of briefly brought up propTypes, and we just had this like big long conversation about it. And from that, we came across this and started talking about it. Somebody was using it. And so what you can do is, if you were looking at code here, yeah, this is definitely not the production version of it. But if you go to propTypes, you'll see the propTypes are still in there. Actually, this is my favorite line of code in React. Do not pass this or you will get fired. I love it every time I see that. This is not the minified version, so I know it's not the production version running. But what you can do to remove the propTypes is there's a babel RC. This babel transform remove propTypes. So if you add that to your babel RC file and do an npm install, no production. It should be stripping out. I can just search for is required in here. Yeah, it's stripped out. So it's still stripped it out, even though I'm not running in production. It's not recognizing production mode right now. If I were to run this server, you'll actually see that the error goes away, the warning, because it does strip it out. Yeah. So to navigate that time and that warning that was up here is no longer there. So if I were to clear it out, the warning's gone. So you want to keep it in your dev code, but you don't want to run it in production code is the idea. And the way that you gauge that is with the environment productions and the plugins.
That's really cool.
Do you know which dev code was eliminated?
Depends on the project. Like for mine, it was 6 lines. Because all I had in my demo was propTypes in a single component. So it would have been, that's the code it would have. So but it could be, I mean, if you have a lot of components, you could look at 20, 30K or more. I don't know, 100K. So, any other questions?
So does that mean you strip it out for size of the
Yeah,
JavaScript?
it's about the size.
But it's not about like the actual how fast the thing renders, because it's going through checking all these things as it's working.
Right, if you're running in dev mode, it will check.
Right.
But when you're running in production, it does not ever check. So why have it code in your production if it's not being used?
Oh, so production already doesn't check anyway.
Right, it
Now you're
ignores.
just stripping it out for file.
Yeah, okay.
That's what I was asking you. Now I understand. So okay.
Makes sense.
So, yeah, it even says, like, I think on the guy's plugin page, basically, remove propTypes from production because they're only used in development to save bandwidth.
Good idea.
Yeah. That's all I have.
That's all I have. That ended up being shorter than I thought. So what do you guys think about the fewer speakers? That was my attempt to go 2 or 3. Whoa, all right, sweet. Let's keep doing that then. And now, hopefully you're thinking, that didn't seem too hard, you know, speak for 15, 20 minutes. I could do that. I could do that. Tyler, I want to speak. Bryan, I want to speak. Please let me speak.
One idea I had for, not for February, but for March, is a hackathon during this time. So I had previously suggested we should get together on a Saturday for a hackathon. And the reason you would do that is so you would have more hours. Has anybody ever been to a short hackathon that was worthwhile? Can it be done? It was just a theory. Like, was it worthwhile?
I learned to React.
You learned React,
Yeah.
so no.